Good morning, everyone, and welcome to the learning discussion about pseudocode. The objective of this learning session is to learn about pseudocodes, how to convert algorithms and flowcharts into pseudocodes, and how we can use pseudocodes to solve problems while thinking computationally. Like flowcharts, pseudocode is a way of planning out the design of a program and engaging in higher order thinking about what the program is doing without the extra cognitive load that comes with working with the details of a programming language syntax. It is also a way to express what an algorithm does that is essentially readable to those without maybe not much expertise with a particular programming language. That also means it can, which is pseudo, can be a stepping stone to learning how to program. And finally, it makes it easier to collaborate with colleagues, especially when working on, say, a large application which has multiple small parts that needs to be combined together and different teams are working on it. So it helps in the communication of the algorithm and the logic for that application or program. Hello again, I'm Rashmi. I am the Director of Digital Learning and Library at Arlington Public Schools. I also work with a nonprofit called STEAM Futures and with the wonderful Leslie STEAM team at Lesley University. Um, you might be wondering what pseudocode is and why it's so useful for writing computer programs. But before that, just sort of revisiting our understanding of what algorithms are and flowcharts are. And it is, um, let's sort of refresh our memories before what the programming and coding constructs are. So, in the simplest, programming is the manifestation of logic. The program is a set of instructions that defines the behavior of your application, and writing code is how you implement it for the machine, right? So, what is pseudocode, right? Pseudocode, before that, here is a quick review of the algorithm and flowcharting, where we discuss that algorithm is a mathematical method of solving problems both big and small through though computers run algorithms constantly, humans also use this process of algorithmic thinking to solve complex as well as simple problems. And then we have seen that flowchart is a pictorial representation of the separate processes that we use, and it's in a sequential order with various geometric shapes, standard geometric shapes embedded in it, like a diamond, which is essentially used for decision making. Okay, so going back to what is pseudocode, um, pseudocode is an informal step for an algorithm using structured English. So there is no specific syntax for pseudocode, and it should be human readable so that a programmer can translate it into program code. Pseudocode literally means fake code. It is an informal and contrived way of writing programs in which we represent the sequence of actions and instructions, aka algorithms, in a form that humans can easily understand. You see, computers and human beings are quite different. We all know that. And therein sort of lies the challenge. The language of a computer is rather precise, and you're expected to communicate exactly what you want the computer to do and to not deviate from the rules of the syntax of the language. Even with the invention of, say, high level languages, or we call them human readable languages like the JavaScript and the Python, it's still difficult for for us average human beings to um, whether they're developer or not, to sort of reason and program in those coding languages. Hence, pseudocode is very helpful in sort of communicating the logic of that. Another way to explain pseudocode is that pseudocode is a simplified representation of an algorithm that uses the English language to describe coding logic. It allows programmers to plan any type of programming um, an algorithm structure using simple written commands and instructions. So, pseudocode primarily uses plain text to describe various coding actions and their correct sequence in the algorithm. Although some types of pseudocode also use mathematical symbols to represent or reference data sets. While programming languages like Java exist for computers to process, pseudocode exists for humans to read and understand the process of the programming. Because computers can't interpret pseudocode, programmers need to translate it into a language, a programming language, to produce a functional algorithm. Programmers can interpret each line of pseudocode into the technical specifications of their preferred coding language. So, simply put, pseudocode is used to formalize steps taken to solve a problem, in this case, an algorithm. Let's imagine that we want to find a long lost friend of ours in the phone book, like in the old age, and the only thing we know is that their name starts with a J, right? So this is a quick pseudocode of that. So let's look at it. One solution would be to flip every page of that book from the start until we arrive on the page J, but that would take too long and it will not be efficient at all. So another solution would be to flip in the middle of the book, then access if J is on the left side of the book or the right side, and then flip towards the appropriate side in the middle again. And do this until we find the J page. This in all regards would be a much more efficient way to find the J in the pages of the phone book. Granted, we don't use phone books at all now, but this is just to illustrate sort of a process flow. And following this one here is an example of how to formalize the pseudocode for the second algorithm that we just discussed. And later in this video, I will also explain and explore the details of how to create a pseudocode from an algorithm and flowchart. So why use pseudocode, right? Because programming languages involve complex technical details, pseudocode is an easy way for people to understand the basics of how program functions without having to learn the complicated mathematical or syntactical notation of a programming language. Programmers often use pseudocode as a prototype before writing the actual technical code for a program, allowing them to sort of informally determine the better way to write their algorithm and plan the layout of a project. Using pseudocode is an efficient way to manage and document one's sort of coding operation or logical operation and the process. Okay, so this is a quick example of a flowchart. And then you have the pseudocode right next to it, and we'll be doing a little bit more of this sort of an exercise later in our video tutorial. So, what are the main constructs of the pseudocode? To properly represent an algorithm, pseudocode includes representations of several elements of programming logic, also known as constructs. These constructs are the structure that explains the various ways of writing the pseudocode, and the pseudocode constructs appear in uppercase as an easy way to tell a reader that the phrase described is a critical action for the algorithm. The primary constructs you use in pseudocode are sequence, if then else, case, for loop, which is a conditional, repeat until, um, and you might have, like, say, for example, repeat, email new customers until 1,000 replies. There's also the while loop, and there are several other constructs as well. Although these six constructs that I just mentioned are the most popular elements of pseudocode, there are many other keywords you can use in your work. Because pseudocode is informal and meant for human interpretation, you get to decide which words to use to represent your algorithm. There is, of course, a standard way of representing it, and there is called a reference language, which you will find in say, let's a project that you're working on, and you might have a reference language. In tests, they usually have a reference language that you use, and I will show you an example of that in the later parts of the learning session. Um, And if you are also using unique custom keywords to represent specific actions other than the six main constructs, maybe it's always a good idea to create a glossary and explain so that the reader who might be in a different country should be able to understand what your pseudocode is. Okay. Um, a quick preview of what the advantages of pseudocode are. It helps in the brainstorming process. It helps in collaboration. It's a simple language which makes it a useful tool in explaining the complex technical details to other stakeholders and collaborators. It is an efficient instruction because once you complete your pseudocode, you can use it as a clear outline for translating each of the line into a programming language. So that's how precise you have to be in your pseudocode. And then it's basically very importantly for documentation. So saving your pseudocode documents can help you record project goals, best practices, and ideal outcomes for project, which can help you make corrections and updates to your program in the future. What are the disadvantages of writing pseudocode? Well, there are a few. Um, Working with pseudocode involves some challenges to consider. If you want to use it for project, it isn't standardized. So you might want to standardize it or use the standard construct or create again a glossary of the terms that you're using. Writing pseudocode also takes time and planning, which means delaying the process of actually writing the code. And But it also, again, the flip side of it is it allows your team to come together and sort of think through the logistics of your process, the flow of your process, and actually not worry so much about the syntax of a programming language that you might want to implement it in. And planning ahead and using efficient, consistent pseudocode practices is an important strategy for overcoming some of these challenges, which of course are a standard practice in the industry and allows you to have the full benefit of the pseudocoding process. Um, these are the few best practices for writing pseudocode. So capitalize the construct keywords, only use one construct per line unless it's a paired construct like if then, and so on and so forth. These are the few best practices for writing pseudocode. Again, this is not an exhaustive list. You can use to improve its function and readability by using some of these practices and adding to them as you iterate through your pseudocode. This again goes into your documentation, as I mentioned before. You can develop your own pseudocode writing style while still following basic guidelines to make it easy for others to interpret your code, instructions, your process, and to collaborate on the algorithmic process, right? Here are as I said, these are the few best practices, and keep iterating and adding to this so that you can be more efficient and responsive and reflective about how you are writing your pseudocode. Now, how to write pseudocode, and we'll talk in detail about this in our other video. Um, but basically, the exact process you use to write pseudocode varies depending on the progress and the purpose of your algorithm. But it involves the same basic steps. It's like creating a flowchart, writing down an action, which is essentially starting by writing down one action for your code to complete. For example, displaying a text on a website, calculating an equation, or printing a document are all actions you can initiate with code. Always begin with the first action in a sequence to keep your pseudocode organized. Set limits. Use constructs to set the limits for the first action in your flowchart. Decide what types of sequence, loop, or conditions you need to make your code work. For example, if you want your algorithm to print certain documents, use the for construct to explain which pages to print. And then combine constructs, which is to modify and combine constructs to create custom pseudocode that describes complex operations. Remember to use indents or another form of spacing to organize groups of constructs, especially when nesting one construct within another. For example, if you start with an if then else construct, that tells the algorithm to print tests for fourth grade students on a blue paper and tests for fifth grade students on green paper, you can then add a repeat until construct that instructs the program to keep printing until you have 100 total tests. So here is a quick example of pseudocode, and I'll try to explain that in our next video. So let's go to give me a quick second for this unit. We are going to be um, looking at just a quick second. We will be doing some readings. We will be exploring examples of algorithms in real life and converting them into pseudocode. We will understand and create, decipher what pseudocode statements represent, and we will discover, reflect, and question our own understanding of how computer codes with algorithms, flowcharting, and pseudocode connects with the real world and the problems in front of us. Um, it is so essential that in this unit, in addition to the readings, you will be creating a pseudocode for the flowchart that you developed for your recipe, and creating the teaching resources for the research assignment, which is essentially how would you teach pseudocode to your audience, to your students, um, to your colleagues. So in this learning session, similar to past sessions, we always urge you to broadly explore ways in which computer science connects with the real world, helps solve problems, as well as enrich your teaching and learning of computational thinking and computer science concepts, processes, and frameworks. Through the various readings, articles, hands on assignments, and interactive exercises, we learn how important it is to be precise and about defining things well, and how hard it is to take into account all the situations that a computer and you, the computer programmer and the algorithm thinking, has to take into account as you write your algorithm or flowchart or pseudocode. So this is just a quick breakdown of some similarities and differences, and highlights. I've also a similar sort of a pictorial map of it. You will be engaging in exercises like these, like writing an algorithm to output um, the largest of the two numbers entered by the user. So that's what you will look at, which is a flowchart. Then we'll convert it into a pseudocode. We will also add or refine that algorithm to add a third input and then find largest of the three numbers entered by the user. So we'll have multiple variables and an output logic. So we'll modify that in our assignment video. And then we will sort of engage with some of these understand, create, and decipher questions, which are you will be given a flowchart, and then you sort of have to look at which of the following pseudocode segment actually correctly represents the flowchart. You might be given another example to answer the question about, which of the following segment, pseudocode segment, produces the same output as the flowchart shown below. So you would be analyzing your flowchart for the output and then sort of looking at the various programming options that are given to you, the pseudocode options, and seeing which one actually generates a similar or the same output. This is another example of a if else pseudocode segment. And then there might be a little bit of a complex uh, question where you will be using the pseudocode to answer the question that follows. So this is just for check for understanding and engaging with a pseudocode in ways, in interactive ways, so that you can create as well as decipher the logic of your pseudocode. Lastly, again, you would be contributing to the research assignment, which is sort of mining for resources for teaching and learning, and that's the process of for the process of pseudocode. Thank you so much. The curriculum postings for this week will provide you with the links and the course materials required for the assignment. We so look forward to answering your questions, chatting with you, and hopefully meeting you in person at the synchronous session. Again, I am Rashmi. You can contact me anytime at these email addresses. Have a wonderful day and have a wonderful pseudocoding experience. Thank you.